Okay, so this lesson goes a little bit deeper into understanding slope, rate of change in slope. We have worked with slope in graphing lines, and we've identified M as the symbol that represents slope, and we've talked a little bit about rise over run. So rise is the up or down movement from one point to another, and then run is a left or right movement. And if your numerator is positive, that means you'll move up that many. If it's negative, you'll move down that many from one point. If the denominator or the run is positive, then you'll go right that amount. If it's negative, you'll go left. Okay, so we can determine slope by looking at a graph and figuring out how we're moving from one point to the other. We can also, so that's using 2 points, we can also use a formula if we're just given 2 points. So here's the formula for the slope using 2 points, and we'll go over examples of both kinds here in just a minute. All right, on this first one, it's asking us to define the rise and run between the marked points on each graph. Then find the rate of change or the slope of the line. So the two marked points are 0, -4, and 5, 0. So we want to start with one of those 2 points. So I just like to go left to right, but it won't matter because we'll get the same slope either way. But let's start with this point. Let's identify the rise. So the rise is, to get to the next point, how many do we have to go up or down to get on the same level as that point? So for this point, I would have to go 1, 2, 3, 4 units up in order for me to get on the horizontal with that point. So my rise would be a +4. And then once I'm on the level, same horizontal line as the second point, then how many do I have to go over, right or left? So 1, 2, 3, 4, 5 units right, and since it's right, it's positive. So up is positive, right is positive. So now we know slope is rise over run, so we can just put the fraction 4 over 5 as our slope. Now, what if we went the other direction? Maybe I started with the right point, okay? So let's talk about what happens there. I started with the right point. So remember, rise is up or down to get on the same horizontal as the second point. So here I have to go down 4, correct? Before I'm on the same horizontal line. So that would be a rise of -4. And then I would have to go left 5 to get to that point. So that would be a run of -5. And when I put that as a fraction, I can reduce the negatives to make it positive. So the negatives cancel out. If there's a negative divided by a negative, that's a positive. They cancel each other out. If there's only one negative, we leave it negative. Okay, so you would get the same answer in terms of slope. Your rise will be different if you go from the right to the left. All right, let's take a look at number 2. We have our 2 points identified, -2, 9, and 1, 3. So starting at the left, I'm going to do my rise over my run. So my rise is the up or down. So in order to get on the horizontal of this point, I have to move down. How many units do I move down?
5, 6.
Would everybody agree? 6? Okay, so our rise is 6, but it's down 6, so we're going to make that a -6. And then how many units do I have to move right to get there? 3. And that's right, so that's positive. So now I can state my slope. It's rise over run. That's a -6 over 3. And we always want to reduce. Now it's a negative over a positive, so it's going to stay negative. 6 over 3 is the same as 2. So our slope is a -2. Some people like to write it as a -2 over 1. That's okay. And of course, we can make the negative just out front of the whole fraction and go -2 over 1 like that. So all of those are acceptable. All right, number 3, we are starting at this point, going to that point. Actually, let's start at the right and go to the left. So from this point, I have to go down how many units? 1, 2, 3 units. So down means -3. And then once I'm on the horizontal here, I'm going to go left 1, 2, 3, 4, left 4. Down 3, left 4. So now I'm able to identify my slope as a -3 over 4, -4. But remember, negative over a negative will simplify to a positive. So your answer should be 3/4. Would have gotten the same thing the other way, except for rise would have been +3 over +4, and there we go. Okay, so let's talk about finding the slope of these using the equation, the formula. Okay, so let's skip over those graphs a little bit. And let's remember our formula for slope is y2 minus y1 over x2 minus x1. And you're doing this in science? Ah. So the x1, y1, x2, y2, those come from your 2 points. So you identify one point as the first point, and that's when you can locate x1 and y1. And then you identify the second point, and that's where x2, y2 comes from. So on the top one, on number 1, from above, the 2 points that were given are 0, -4, and 5, 0. Okay, so I'm going to, the first point I list is going to be my point 1. So this is going to be x1, this is going to be y1, this will be x2 because it's from the second point, and that's going to be y2 because it's the y coordinate of the second point. And this is from the problem number 1. So we want to get a slope of 4/5. We'll see if we get that using the formula. Okay, so we're going back up to this formula right here. Our slope is going to be y2 minus y1. That's what goes in the numerator. So m equals y2 we identified as 0, right? So 0 minus y1, which is a -4. So y2 is 0, y1 is a -4, y2 minus y1 would be 0 minus a -4. Now in the denominator we're going to take x2 minus x1. So x2 we've identified as the number 5 minus x1 is 0. And simplifying now, 0 minus a -4, that just, the minuses cancel each other out. Subtracting a negative is the same as adding the positive. So in our numerator we get 4. 5 minus 0 is 5. That's 4/5. Is that what we got on the first one above? Graphing. Yes, it is. Okay, let's take a look at the second one. And the points from the second one are -2, 9. And 1, 3. Okay, I use the first point that I list as my point 1. So that's where my x1 and my y1 come from. The second point is the point 2, and that's where x2 and y2 come from. And so now I'm ready to work out use the equation to find the slope. So numerator, Evan, what are we going to take? What minus what on the top? y2 minus y1, 3 minus 9. And the denominator, Hadley, what minus what? 1 minus a negative 2. So then we can go ahead and simplify. 3 minus 9 is a negative 6. 1 minus a negative 2, remember subtracting a negative is the same as adding a positive. And that gives us 3. And we want to reduce. 6 over 3 gives us 2 over 1, but we have a negative 2 in the top. And that's the same slope that we got above. Now, something that you can do to check your work is if you're given the graph of a line and you're trying to find the slope, if you read the graph as you go left to right and the graph moves up, that means your slope is positive. So did we get a positive slope here? Yep. If you move it left to right and your graph goes down, then your slope is negative, and that's what we got here. And so then on number 3, the graph goes up from left to right. That means it's got a positive slope, and that's what we came up with here. Okay, so what I want you to do right now quickly is use the 2 points from number 3 and find the slope, and then we'll work those out to double check together. And then I've got a couple more I want to add for you. What are we subtracting in the numerator? Did you choose this as your first or second point here? First. So we go y2 minus y1. So if you do 1 minus 4, did you do 0 minus 4 on the bottom? Okay, so then that's okay. You're actually counting this as your second point. So whatever point you start with your y's, you have to start with your x to find the slope. So he started with this point, so he's actually making this as point 2. So he went 1 minus 4, right? Y minus y. And then in the denominator, what do you have again? 0 minus 4. So that's a negative 3 over negative 4, which reduces to 3/4. For what I have identified up here, my y2 would be 4, y1 is 1, so I'd go 4 minus 1. x2 is 4, x1 is 0. That gives me 3/4 as well. So, very good. It doesn't matter which point you choose as your first point or second point. You should get the same answer for your slope. Okay, so let's add this problem now. You don't have the graph for it, but here's the 2 points. The first point is negative 5, negative 1, and the second point is 2, negative 1. So use the slope formula or graph it if you want to and determine the slope. Greater. What did you subtract in the numerator? Okay, so remember this is your x1, this is your x2, y1, y2. We always start with the y's in the numerator. So what are the 2 y values? Negative 1 and negative 1. So I'm going to take a negative 1 minus a negative 1. And then in the denominator, 2 minus a negative 5. And that reduces to 0 over 7. What's 0 over 7? Just 0, right? So our slope is 0. We could also see that on our graph. If we went back to our graph, if we plotted the point negative 5, negative 1,